Hey everyone, my name is Miles Catuli and I'm one of the SIs for Chem 1B this quarter, and today we're going to cover partial pressure, so let's just jump right into it. So before we do any practice problems, I just wanted to overall cover the general concepts of partial pressure before we get started. So the first thing I want to talk about is an idea called mole fraction. And we denote that by x. So what mole fraction is? So mole fraction, so xi, and I is just going to be some gas that you have, is going to be equal to Ni, so whatever the moles are for that gas, over the N total, over the total moles of a gas mixture. So let's say, for example, I have a vessel of gas and it contains H2 and O2. And let's say I wanted to calculate the mole fraction of H2, right? And the problem tells us that H2 has 0.8 moles and O2 has 0.2 moles. So how do we solve this? So we would take the moles of H2 divided by the moles of the total gas. So that'd be equal to 0.8 moles divided by the total, which is just adding these two together. So that'd be 0.8 moles plus 0.2 moles. So if you do this calculation, you get 0.8 moles over 1.00 moles. And you can see that the moles actually cancel. So this value is unitless, so it has no units to it. And the answer would be 0.80. Just 0.80, no units. And mole fraction in general has no units to it. Next, I want to cover just partial pressure and a big concept to take away. So the big thing with partial pressure is that if you, again, have a vessel with a bunch of gases, let's say H2, O2, and N2, just for example, that the pressure of each gas is going to be proportional to the number of moles for that gas. So for example, let's say that you have H2, O2, N2, like right above, and let's say H2 has 0. 0.2 moles, O2 has 0.3 moles, and N2 has 0.5 moles. Right? So what gas between these three would have the highest pressure? So based on this idea that pressure is just proportional to the number of moles, the gas with the highest number of moles would have the highest pressure. So for example, in this case, it'd have to be nitrogen. So nitrogen would have the highest pressure. And then that means hydrogen would have the lowest pressure, and that O2 would be in the middle pressure. Yeah. So highest, low, and middle. Yeah. So the pressure of a gas, let's say I have a lot of moles of a gas, that's going to be equal to a high pressure. Just an idea to take away. Awesome. So moving on to an actual example. Here you go. So this first one in 10.97 is asking us what is the mole fraction of H2 given N2, H2, and CH4. Right? So let's write that out. So mole fraction of H2 is going to be equal to N of H2 over N total. Right? So that's going to be equal to the moles of H2 is given right here is 0.2. And then the N total, we're going to just add them up together. So we have 0.7 plus 0.2 moles plus 0.1 moles. So that's going to be equal to 0.2 moles over 1 mole. So that means the partial pressure of hydrogen, in this case, is just going to be 0.2. And again, no units. Awesome. So that'd be the answer for this first problem. Now moving on to the second problem, it's asking us to calculate the pressure of the gas mixture. So that means it wants to find the total pressure of all these gases, N2, H2, and CH4. And to do this, we're going to use the formula we've been using. So we're going to use the formula PV equals N or T. And the reason we use this is that we're given, or we can calculate for all of these variables. So N, you can see that we just calculated it, so we're going to use the N total because we're looking at all the mixtures. We're looking at all three of these gases, and we did that 1 second ago. That's going to be this 1. So that's going to be the N. The R is a constant, so we don't have to worry about that. The temperature is given to us right here, 10 Celsius. The volume is also given to us, 0.75 liters. And then this pressure right here, this is what we're going to calculate for. So let's just rearrange this equation. So if we rearrange it, we're going to get P is equal to N or T over volume. And again, the moles we're going to use is the moles of the whole mixture because we're looking at the total pressure. So we're going to use the total moles. And that's going to be, again, right here, 1 from the other problem. And then the N again is 0.08206 liters times ATM times moles times Kelvin. And then the temperature is given to us as 10, but that's in Celsius. We want to convert to Kelvin, so we're going to add 273 to it to get 283 Kelvin. 283 Kelvin. Divided by the volume, which is given to us again, 0.75 liters. So if we do this calculation out, and we cancel everything, we're gonna get a value of 31 ATM. So that would be the P total, 31 ATM. Okay, whoops, never mind. So what we're gonna do next, so we're gonna look at this, and we're gonna calculate the partial pressure of each gas, right? So we have 3 gases. We have H2, N2, and CH4. So to calculate the partial pressure of each gas, we're going to use another formula. And this formula is going to be the pressure. So the pressure of H2 is going to be equal to its mole fraction, right? And its mole fraction, so we have 0.2 because we just calculated it 1 second ago. So we have 0.2 moles, or sorry, 0.2. The mole fraction times the total pressure, so 31 atm. So if we do this calculation out, you get a value of about 21.7 atm. And then same thing for N2. So if we want to find the pressure of N2, we're going to take the mole fraction, which for N2, let's see, that would just be 0.7 because we're taking 0.7 moles divided by the total, which is 1.0 moles. So that's going to be 0.7. So 0.7 times, again, 31, because that's the total pressure. Oh, whoops.